Now that you've learned how to display items inside a SwiftUI list view and work with the identifiable protocol, let's get our app ready to do some networking. Our networking code will use the URL session and decode a JSON response using the JSON decoder, similar to what we've already done in the Klima and the Bytecoin modules. But let's see how this will work in a project built with SwiftUI. So inside our Hacker News app, I'm going to create a new group called Models. And inside this folder of models, I'm going to right click and create a new file, which is going to be a Swift file. And I'm going to call it Network Manager. Inside this file, I'm going to create a new class called Network Manager. And then I'm going to open up a set of curly braces. This network manager is going to have a method called fetch data. Doesn't take any inputs, but it does do quite a few things. So the first thing it's going to do is to create a URL from a string. So we're going to do the same as we did in Klima. We're going to create it from the URL initializer, and we're going to use the one that takes a string to create the URL. So the string in this case is going to be from our Hacker News API. And if you read through the documentation on this page, hn.algolia.com/API, you can see that we can get hold of all the stories that are on the front page by using this particular query. So this is going to be the URL that I'm going to copy. And firstly, I'm going to test it in my browser just to make sure that I actually get data back. And notice how I've got the JSON awesome again activated. So we already looked at this in the JSON lesson, but it means that I can take a look at the structure of the results that we would get back from this request. So you can see that we get an array of 20 items, which is stored under something called hits. And for each item, we get a whole bunch of details about each story in Hacker News, including the number of points, the title and the URL, etc. So this URL seems to be working. So let's copy it and paste it into here as the string of the URL that we're going to make the request to. But of course, because this initializer creates an optional, let's go ahead and wrap this inside an if let. So if we are able to generate a URL from this string, which I'm pretty confident that it can, then we're going to create a session object from the URL session class, and we're going to initialize it using a default configuration. Next, we're going to create a task, which is going to be set to session.dataTask, and we're going to choose the initializer that takes a URL and has a completion handler with the data that we get back, the response, and the error. So the URL that we're going to be using to make this request is, of course, the URL that we generated up here. And then in the completion handler, I'm just going to select it and hit enter so that it splits it into a trailing closure format. So the data is going to be called data, response is going to be called response, and error is going to be called error. So now inside this closure, I'm going to check to see that if error equals nil, so there were no errors, make sure that you don't check that it's if error does not equal nil, which you might be tempted to. If there were no errors, then we can assume that we did get some data back. And of course, the data we get back is in a JSON format. So we have to figure out how to refactor it. So first, we're going to create a decoder, which is created from the JSON decoder. And then we're going to try and get our JSON decoder to decode the data that we get back from our networking session. In order to do that, though, we first have to create a structure to represent all the properties that we want out of this result. So again, inside the models folder, we're going to create a new file. And this file is going to be a Swift file, which is going to be called our post data. And here I'm going to create a struct called results, which is going to, of course, conform to the decodable protocol so that we can actually use the JSON decoder to decode our JSON data into a result struct. And the result struct is going to only have a single property, and that's going to be hits. Let's create a hits property. So make sure that you spell it exactly the same as you see in the response JSON. So HITS. And the hit is going to have the data format of an array of post objects. So at the moment, it doesn't know what a post is. So let's define our post object. Now, our post object, again, has to conform to the decodable protocol. And the properties that we're interested in each of these posts is going to be the title, the number of points that the story got, so how many people upvoted it, as well as the URL. So let's create some properties here. So first, I'm going to create the points, which is going to be an integer. And then I'm going to create my title, which is going to be a string. And finally, I'm going to create a URL, which is also going to be a string. Now, the last thing I'm going to add to my post structure is this object ID property, because this is the number that uniquely identifies each of these posts in the Hacker News database. And it's what we're going to be using as the ID to identify each post in our project as well. So let's create the object ID, so capital I, capital D. And if I remember correctly, it's actually a string. So it's got the quotation marks around it. All right, so we've now created our post structure, which is going to decode from that result JSON all four of these properties that we're interested in. And notice how here it says an invalid redeclaration of post. And that's of course because in our content view, we already created something quite similar. So remember how we created this post structure to be able to create post objects that we can put into an array and render on our list? Well, this is what we're going to be doing with this post structure instead. So let's go ahead and delete this structure and instead head back to our post data and make this post identifiable. Now remember that in order for something to be identifiable, it must have a property called ID. So let's go ahead and create that ID. Now this ID property has to have the name ID, but you'll notice that we've actually already got an identifier which identifies each post. So how can we turn this ID to equal to the object ID? Well, we can use our computed properties. So instead of creating a let, we can create a var called ID, and it's going to have a data type of string. And then after opening up a set of curly braces, we're going to return the value of ID as an object ID. So now, whenever you try to fetch the ID, it's going to look at the value of object ID and assign it to this property as well. So that works around the constraints of the identifiable protocol. And just as a reminder, we need the identifiable protocol in order to use that structure inside our list and for the list to know how to order each item. So now that we've created our results and our post, we're now ready to decode our data. So let's head back to our network manager, and then we're going to use our decoder to decode, and the type is going to be our results.self, which is the data type of that result struct that we created here. And the data that we're going to be using comes from here. But of course, this piece of data that comes back from the networking is an optional. So let's first go ahead and optionally bind it to something called safe data. So if let safe data equals data, well, in that case, we're going to be able to use safe data in here, and that will allow us to work with a non-optional piece of data. So decoder.decode, this decode method, because it can throw, it means that we have to call it using the keyword try. And if we want to catch any errors that occur during this process of trying to decode, then we should wrap that method inside a do catch block and print any errors that occur as a result of this method. Once this data has been decoded, we can bind it to a constant called results. And now we can use our results to populate our list. But before we can do that, we must make sure that our task, which you see in this warning here, that we created this task, but we actually never started the task. So outside of the curly braces of the task closure, so right here, or you can count from the bottom, 3 closing brackets up, we're going to say task.resume, which starts off our networking task. So that should get rid of that warning, and now we can address our results. Now, how do we get our data that's in our network manager over to our content view? Given that our SwiftUI components all need to monitor the state of a piece of data. And we'll answer exactly this question in the next lesson, where we learn an advanced state management technique that uses the observer design pattern.